head carried.
As a new era of fast 3D printers emerges, we witness a surge in proprietary components and designs. Yet, there are those who remain steadfast in their desire to build one from the ground up, with hopes of keeping the spirit of rep-rap alive and thriving. The very same design philosophy that started all of 3D printing, do-it-yourself self-replicating printers.
With a budget of just $300, I was on a mission to build a very fast 3D printer, a do-it-yourself Bamboo Labs killer.
Join me in my journey as I build a Core XY 3D printer from scratch, a 3D printer tutorial with a never-before-seen welded steel frame approach made from home construction materials, things I found from the flea market, and a bunch of spare parts that you might already have lying around.
Let's see if I did succeed, or did I go over budget.
My journey began when I went to a nearby hardware construction store as I bought some lumber supplies for building another steel table. From where I come from, $4 would get you 6 meters of 1 by 1 inch steel tubulars. It got me thinking, I haven't seen a single Voron printer or any 3D printer, to be frank, that has been built upon a steel frame. If I were to do so, I'd save hundreds of dollars for building one of those next generation of fast 3D printers by replacing the traditional aluminum profiles they are built upon. And me being the nerd I am, I always doodle on my notebook during my free time. How much steel would I need to build one of those fast Core XY 3D printers? 5.24 meters. That is within an astonishingly low budget of $4. Cheaper than a burger at McDonald's. This project got me so excited, I skipped all the CAD work and just straight up ditched my plans on building that welded table and just started cutting all the metal based on my doodle. I guess I'm building a 3D printer now. This is one of those freestyle projects of mine that would probably get my engineering degree revoked. I don't have a proper welding table with me as of the moment, so I had to make the most of what I got. I have this homemade workbench, and I did grab some sacrificial pieces of wood so I could have a relatively flat surface to weld on. I eventually resorted to using clamps to fasten the tubulars on the table, and a 45-90 triangle I used back when I was in uni for ensuring I get close to 90 degrees on my weld angles. This is my first time using a MIG welder, as I just got this Harbor Freight Philippine equivalent to replace my old arc welder. So please forgive me for my horrendous welds. I am an electronics engineer and this is not my forte. If you're going to ask me why I'm molding it peg by peg and not use all the magnetic clamps I have, that's because from experience back in the pandemic when I used to build lots of tables here at home, I get better 90-degree angles with a triangle instead of using all those magnetic clamps. In Filipino we say paghinang ng skwala, which closely translates to be able to weld at a perfect 90-degree angle. And that's what I tried to do. My friend suggested me the slow and painstaking process of using the triangle 1 by 1 peg by peg to help give me some sanity whenever the welds tend to warp the steel, and whenever it does, I give it a little nudge and it's back in place and I continue to weld even more. The main goal here is simple, to be able to build a perfectly cubed frame. Well, I mean, technically it's a rectangular prism, but you get a picture. Don't be scared, it does not have to be perfect. In 3D printing, we have a firmware, and that firmware can compensate for that error or that 3-dimensional skew error to an extent through calibration. In my specific design, you'll eventually find out why the bottom does not have to be extremely precise, unlike the top frame and the spine. My MIG welds eventually got a tad better, but they're still nowhere near perfect, so I got my angle grinder to smoothen the surface to save the day. I had to add a spine for my gantry's Z-axis by cutting my remaining scraps of steel tubular to form a 1 by 2 inch backbone instead of buying another set of steel with a different dimension. I got a little lazy and dots of weld would do. I brought it to my cutoff tool to cut it to a specific length that would fit in my frame. And that's perfect. I then grabbed a ruler to get the midpoint of the top frame and marked it with a Sharpie. And also a quick tip, a T-square would help you a lot in the Z alignment. Use it to translate the marking from the top frame to the bottom frame to keep the Z-axis spine perpendicular to the top XY plane frame. This was done because I was an assumption that the frame is nowhere near perfect. I don't usually weld, I only do it when I need it. I'd be more than happy to hear some feedback or comments on how I can make them better, as it might help others in the comment section as well. There's actually a saying, when your welding sucks, let the angle grinder save the day. And that's what pretty much happened to me. Overall, I was quite happy with the outcome. It wasn't perfect, but it was better than I expected. post-measurement showed me that the errors are workable, and I eventually came up with ways on how to work around that. This isn't my first 3D printer build, and upon seeing the frame, I was quite optimistic with what the rigidity of this thing can bring me. This video is not sponsored by eGizmo. However, I would love to share my favorite mechatronics store here in Manila. I went here specifically to look for linear rails for my 3D printer sliders. These things are extra rigid and are relatively light compared to roller assemblies. They are often found in high-precision industrial machineries and assembly lines, or perhaps in CNCs as well. In this shop, they do sell them for around $10 a kilo, and that's more than enough to get me 3 THK branded linear rails for my 3D printer's XY gantry. As for my Z-axis, I'm going with a linear actuator. But what really caught my attention was this Yamaha servo-based actuator. As much as I would love to use this for my printer, I have no idea if Marlin or Clipper has native support for the drivers this thing comes with. So I went with this. It's a ball screw linear actuator without a servo. Luckily, this is a lot cheaper. However, I would have to make a custom faceplate for it to work with NEMA 17 motors. At $90, ironically, it's going to be the most expensive component in my printer. It was a luxury purchase, and it was only justified to further simplify the design and build process of the printer. Upon checkout, they do some slight restoration on the linear rails. Today was indeed a good day. After I drove back home, I continued building the printer. I grabbed one of those linear rails. The ones available were a tad longer than what I needed, so I'm going to cut the steel rails. If your carriage does come with guards, you can just simply slide the rails off the carriage. I proceeded by marking the measurements of my cuts. Then eventually I brought it outside to my cutoff tool for cutting my linear rails. Quick disclaimer, this would remove the rust coating at the ends of the rails. You also might have to file the edges for the carriage to slide back in smoothly. As for the excess rails, I'm going to save the scraps for a future Voron Zero build. For mounting the rails, I first drew a scratch guide using a caliper and a marker. I have plans on giving this a heated chamber, so the carriages must be within the bounds of the frame as so not to protrude with the side panels. After marking the holes, you can translate your measurements to the other side using a T-square. With the assumption that my frame isn't perfect, to get both rails aligned parallel to each other, I used a T-square, a ruler, and some clamps. If the edges don't match, loosen that clamp and slightly move your ruler until they have equal lengths from the other end. After that, you can finally write the guide for the parallel line and the holes. Before you drill, please do use a punch tool so that the bits won't slip during the drilling process. I'm going to use M3 bolts, however, I wouldn't pair them with nuts. Instead, I'll be using my hand tap set for tapping threads so that my bolts would fasten directly to my frame. If you are one silly person, please don't force thread a bolt directly to steel without using taps. It wouldn't work. I was once that silly guy. Same thing for the extruder brackets. Mark, punch, drill, and tap. And yes, the tap works with the drill if you are lazy. It also applies to the front pulley brackets as well. Silly me, no marker would fit the hole, and luckily I had a failed aborted print of this bracket which I used as a stencil. Next would be the holes of the linear actuator for the Z-axis. Just find the midpoint of the frame and the actuator before marking the holes. Same thing applies, but this was a bit trickier since I would sometimes have to fit my entire head within the frame to see the marks properly. By now you probably know why I didn't pre-drill this with my drill press before welding. Mostly due to the post-weld compensation for the measurements. You have the freedom to choose where to mount your 3D printer's controller board. I decided to mount mine at the back spine. And that's pretty much how you drill threaded M3 holes on the frame for most of the components. I did miss some of the holes and you'll eventually see them later. The following morning, I spray painted the frame with a can of primer gray spray paint. It does help a bit with the chipping problem of directly painting your colored can of choice. I decided to give it a matte black finish as it was my favorite monotonic theme for most of my DIY machines. While I wait for the paint to dry, I continued with some other things, such as modifying that ball screw linear actuator I got earlier. The chunkiest linear rail with a ball screw in the middle I have ever touched. And just what I suspected. An NEMA 17 motor won't fit in the screw mounts of that actuator. So I had to add a coupler and that custom faceplate I was saying. I 3D modeled and 3D printed it, then added some heated inserts. It took a little courage from seeing it from the shop down to implementing that improv. I was then faced with another problem from that adaptation. It created an unwanted incline from my frame. Instead of using lame washers for elevating it, I grabbed a rotting flat bar and put my old scraps to good use as chunky spacers. I had to use 2 strips to make a proper spacer for this. That steel might be a bit too thick for my cordless drill. I guess this is a job for the drill press. If you don't have one, you can either decide to ruin a bunch of good bits with a cordless drill or just simply use a bunch of washers if you feel lazy as of the moment. Be careful of the metal shavings, and JC, please do forgive me for ruining your pasalubong. And that's how I made 2 copies of those flat bar spacers for my Z-axis. The paint has dried and I can finally mount my other components. It doesn't have to be in any specific order, but I did start by mounting the Z-axis actuator on the frame. Some of my video files got lost and I won't be able to show you how I welded some flat bars to form this cantilever bracket for my heat bed and linear actuator. I also messed up the distance between the holes, so I was forced to add another pair, got lazy, and just mounted 2 bolts to fasten it. Regardless, it's still exceptionally rigid and looks very minimal. I had a spare Ender 3 heat bed lying around, so that's what I'm going to use for this build. I also had to solder some wires to the heating element and the thermistor. The heat bed being my spare also came with springs and bolts. The process for this one is pretty standard and it's just like assembling any other 3D printer. And then let's install the knobs it came with. Turn it all the way up until you can no longer screw it. This is where I get custom cut Ender 3 size glass beds here in Las Piñas for $1. Call me old fashioned, but I still prefer to use glass beds up to this day. Rinse the glass with water. As for adding extra layer adhesion for prints, this is my favorite can of hairspray since 2015 for 3D printing. I'd usually reapply a layer every 6 months, and the key to longevity is a day of curing under the sun. Once the layer has dried, you can finally put it on top of your heat bed. To fasten it, you can buy 3D printing bed clips, or if you want something much easier to find, the classic butterfly clips would also do. I do prefer the bed clips as they consume less usable print area compared to the butterfly clips, but that's pretty much up to you. This is most of the plastic components needed for the build, the perfect example of a 3D printer replicating itself to build another DIY 3D printer. The first ABS plastic that we're going to mount are the stepper motor brackets. I designed them to be mounted by 3 bolts, 1 on top and 2 from the side. Once done, you can install a stepper motor on that bracket. The motors that I'm using are $4 NEMA 17 48mm steppers from Circuit Rocks. Rated at 1.8 amps each, it offers good torque for budget Core XY builds. Sadly, I am using the classic dual gear drive Bowden extruder for my assembly, since I had a few of them lying around. As much as I wanted to go direct drive and use an orbiter, my current setup is cheaper, lighter on the print head, but comes at the expense of print quality. Moving on to the XY joints, force threading screws directly on plastic is a bad idea. The least I would do is embed some threaded heatset inserts on my plastic. A regular soldering iron tip would do, but I prefer these non-tapered ones as they don't lock onto the threads. Just some quality of life accessories for my do-it-yourself Faco 907 iron. I printed them on ABS, so 270 degrees would do. You'll need 4 16-tooth idler pulleys and 2 smooth idler pulleys. I have the M3 variant, so I grabbed some M3 washers and some recycled M3 screws from my box. Be sure to add a washer in between the pulley to elevate the bearing from the plastic surface. Then screw in your M3 bolt. This one's for the left and this one's for the right. I have plans for revising this in the future, but this would do for now. As much as I wanted to use a 1/2-inch tubular for the X-beam, I still had some excess 2020 aluminum profile left, so I'll use that instead. Measure the distance between the dual Y carriage and cut your X-beam of the same length from your measurement. The same length with your last linear rail. My X-beam assembly included the profile, the rail, and 5 M3 T-slot nuts with bolts spread evenly across the beam. I recommend the chunky nuts as they hold better than the slim ones. Installation is simple. Partially screw in your nuts with the rail, then slide in the aluminum profile. I also want to hear your thoughts if the profile was necessary and if I could just make an XY bracket that screws in directly to the rails for a lighter assembly. I don't know. Anyway, to install the carriage back to the rail, just simply use your thumb as a guide and slide it back in place. Moving on, slide in the right and left XY brackets to your X-beam. Don't tighten them completely just yet because we still have to screw them on the dual Y carriages. Adding some washers would help as long as you have ones that are tiny enough not to touch the pulleys. Then again, don't tighten everything just yet because we still have to align them. Your X-beam needs to touch the frame on both ends before doing so. If it does, you can tighten your X-beam. For the slight parallel alignment, slightly loosen your Y rails and abruptly slide the X-beam back and forth until you barely feel any resistance left. If so, fully tighten your rails once more. Your X-beam should glide smoothly like butter. Also, refilling the grease on your carriages might help. Here's how you assemble the front pulley bracket pair. Grab two 16-toothed idler pulleys, two washers, and a long M3 screw. Add a washer on top. Partially insert the screw, slide in one pulley, then add a washer after it, and add the final pulley. Use your screwdriver to force thread your screw on the plastic. Do the same for the other pair, then install them on the frame. The assembly should now look like this. Both front pulleys should be in line with the frame. A quick sanity check with the leveling. Even without jamming the bed and springs, I was quite happy with how level the assembly was. Here's my 3D printed design for my printhead. It's quite simple and light. This one screws on to the X carriage, and I designed this one to go with a V6 hot end set or a Triangle Labs Volcano CHC. The aluminum bracket screws in like this. For the heatsink cooling fan, I'm using a 3010. The wires are routed on the back, so you might have to unclip them from the fan. I then screwed them in place with just two M3 nuts for weight saving. I then mounted the V6 hot end in place. As for my part cooling fan, I'm using the infamous 4010 blower. The same thing applies to the wires. You might have to unclip them as well and screw them in place. For this build, the X and stop limit switch is installed on the printhead carriage with wires soldered to the common and normally open pins. A zip tie would help with the cable management. For the short wires, I extended them with a flat cord to a length enough to reach the controller. Oh yeah, also please do use heat shrinks. For the severed 2-pin JSTs, set them aside as you can use them once more. A quick segue, this is the Mark II, my first Core XY 3D printer build before the Mark III shown in this video. On this one I did add a bed leveling sensor and used the Volcano V6 hot end. Since I have a new printhead design for the Mark III, I'm going to copy that to my Mark II and also upgrade the V6 with a 120-watt Triangle Labs Volcano CHC clone. To top that off, I'm going to use this 0.6 Volcano CHT nozzle for faster prints. With the bed leveling sensor, there are more wires to manage. It made me want to go the CAN bus route, but I had to stick to my budget. Back to the Mark III, I printed this nice cover for my printhead. Maybe someday I'll add some magnets to make it a quick detach. This is my old design where the wires go through it. Please don't judge me for the accessibility. But anyway, grab some screws, whatever screw fits, and screw that in place. Adding a jumbo heat shrink would also help reduce the strain on the wires. This is a nasty Bowden setup. Luckily, I have a box of PTFE tube spares back when my CR10 had a Bowden setup. I went with the blue Capricorns as they are better in terms of reducing internal sag. Move your printhead as far away from the extruder and cut your PTFE tube to the shortest possible length with the least amount of bend or strain. I had these old nylon cable sleeves from my CR10 when I modded it heavily back in 2017. I said, why not reuse them? So I did. They're kind of pretty. I like how the printhead came out to be. We're not done just yet because we still have to add a fan duct. 4010s aren't as bad as they call it to be. It's just most design and use highly constrictive duct designs the 4010 can't handle. So I made my own. And the printhead is finally done. And just like any other 3D printer, I am using the standard GT2 timing belt for my Core XY build. Also, print 4 of these belt clips and grab some zip ties. I then installed an inverted 20-toothed pulley on the left stepper motor and another one on the right pointing upwards. Move the printhead to the center of the gantry as we will be installing the lower belt loop. Grab your timing belt, insert the belt clip, and insert it to the lower left slot of the printhead. Fasten the clip inwards, then grab some zip ties to prevent the excess ends of the belt from dangling. Route the belt on the left XY bracket's front pulley, then around the left stepper motor, all the way through the front left pulley, to the right pulley, back to the XY bracket's tooth pulley, and finally back to the printhead's lower right belt slot. As for the top belt loop, everything is similar except that the path is mirrored. You can use this similar reference design from RepRap's website. Here's how I implemented my adjustable end stops. The Y end stop is mounted on the rear frame, pushing against the X beam, while my X end stop is mounted on the printhead itself, all configured as normally open switches. For my Z end stop, while I could have used another limit switch, I opted to use the Savage inductive proximity sensor for higher precision and reliability. It's wired the same way except I had to power it. I used 10mm standoffs for my 3D printer's controller board for elevation. For this build, I chose to use the well-known silent 32-bit controller board upgrade for 3D printers. the Big Tree Tech SKR Mini E3 V3. It has excellent support for firmwares and has a big community online. While this is not a popular choice for Core XY builds, this is more than enough for my low-budget build. The elevation was done to prevent the PCB traces from touching the frame. It was also off-centered for me to have quick access to the micro SD card slot. Installing a 3D printer is as easy as assembling a personal computer, as they usually come with standard connectors, except for the ones that are binded to the screw terminals. With a little bit of cable management from the stepper motors, print head, and extruder, I did my best to cleanly route the wires all the way to the controller board. I made this breakout panel with a mini USB port and an XD60 connector for an external power supply. I just wanted to access these ports cleanly all in one place. Unlike in my Mark II build, I routed all the wires of the bed all the way to the top, then going down to the controller, since I have plans of adding a glass panel in the future for making this an enclosed printer. My spool holder is made from the same tubular steel I used for making the frame of the 3D printer. These are the wires for the LCD, and I did 3D print some brackets to make this work with my frame. I also printed this shaft for my favorite generic ABS filament spool. Lovely. For my LCD, I'm using the cheapest one I could find, the C-Tech Mini NeoPixel RGB LCD. Eventually, I have learned that it was not compatible with my SKR Mini, so I had to be creative and made my own cable for it. I also superglued some female headers to make an improvised 10-pin connector. By the way, here's a graphical diagram of my connections. I 3D printed an enclosure for my LCD, screwed it in place, and connected the homebrew cable to it. This one goes conveniently right in front of my 3D printer's frame. Don't forget to add the knob, then connect your cable's connectors to your controller board. It's up to you if you want to add a filament runoff sensor so that your print would pause if the filament runs out. Mine was a homebrew one I designed and used for all my past 3D printers. Initially, I wanted to use this chunky 24V 30A power supply I repaired a few years back. However, it was so big I had nowhere to mount it without ruining the minimalist aesthetics of my build. Thus, I made a quick connect IEC and XD60 shroud to turn this to a safer external power supply that will eventually power 2 other future 3D printer builds. For remote prints, as of the moment, I'm running 3 instances of Octoprint on one Raspberry Pi 4, which is why I made that quick access USB port connector. I do have plans on migrating to Clipper as I need to implement input shaping in the future. In this part of the video, I'm going to skim through on how to compile a custom Marlin config for a Core XY 3D. This is the cauliflower tool and test by Vector 3D. You print this coaster, measure the edges using a caliper, and use this provided Excel calculator. My Mark III has an astonishingly low 0.17 degrees skew. You simply have to just paste this to your Marlin firmware and it fixes the skew error. My Mark II build, on the other hand, had a different story. The physical alignment was relatively bad as it was skewed by 1.28 degrees. I then enabled the XY skew compensation and printed a second benchy to compare. 0.24! That is a big difference. Upon putting the before and after prints on top of each other, you'll find a noticeable difference. I can't cover all the calibration I did for this video, so here's my checklist of things to do. I did everything except for the input shaping as I am about to migrate to Clipper really soon. Before I get to the test print, here are some quality of life upgrades I did outside of the budget. I had an old webcam lying around, so I dismantled it and 3D printed this magnetic webcam bracket. It clips anywhere onto the steel frame. The view isn't pretty, but it's great for monitoring prints. The Mark II isn't using an external power supply. I was able to maintain the minimalist look by equipping it with a really dense 24V 400W LED driver. It had a noisy output, so I made an LC filter for it. I also added a PTFE guide for the spool's filament to help guide it through the runout sensor and the extruder located from behind. I also made this wooden shroud wrapped in CF wrap to make the bottom pleasing to the eye. I had some aluminum scrap, so I handcrafted the XY brackets for the Mark II using a jigsaw, a file, and my cordless drill back at the time I didn't have the drill press. I also added some heat sinks to the steppers to keep them a little bit cooler. It's time to show what these printers can do. With a layer height of 0.15, a travel speed of 500, a true print speed of 150 at 6K acceleration, the Mark III was quite stable. At its normal speeds, it's most definitely faster than my old printer's absolute max. Here, I subjected the benchy to the worst possible lighting conditions to highlight the imperfections. With a thin wall of 0.8mm, the hull of the boat seems to be quite good. The overhangs on the windows and holes shows that the 4010 fan is doing a decent job in cooling. The edges, however, could be better, but that's just about the limits of this Bowden extruder's setup. Also, here's a sample print of the classic wavy vase. I'm quite happy with how the initial prints came out to be for the regular speeds of this printer. But how far can we push it? Well, that's about it for the Mark III, as the V6 hot end creates a bottleneck. However, while the Mark II has the same setup, it has a 120-watt ceramic Volcano CHC hot end, a Triangle Labs clone for $20 that's worth every penny. With it, I was able to push the printer at even faster speeds until I've reached the limit. Without input shaping, this is the fastest it can do as of the moment. With a travel speed of 700 and a true print speed of 350 at 15K acceleration, this thing gave me so much anxiety. I pushed my printer to match the Bambu Labs 12-minute 3D Benchy record, and while I've hit the same time mark, the print quality didn't quite match up. In my setup, the Bowden extruder and the absence of features like input shaping, linear advance, and flow compensation were major factors. I have a long way to go if I want to match that printer. So would I recommend building a fast 3D printer from scratch? No, not unless you find enjoyment in the building process and have enough time to spare. This project was only made reasonable since I have a bunch of old 3D printing parts I have accumulated over the years. It's just another way for me to put those rotting parts to good use. So would I buy a Bambu Labs? Most definitely. Perhaps in the future when I have the budget. But for now, I'm quite
Oh, that's... yeah. That's kinda dark side.
This video is sponsored by World Anvil.
Not a murder.
Oh, my old master. A murderer. Come on, Padme. He wouldn't hurt a fly.
Oh.
Couldn't assassinate anyone. It's not in his character.
Oh, is that so? A Jedi couldn't assassinate anyone.
Yeah, why?
Breath. I haven't seen her in 10 years, Master.
That does seem suspicious looking back. You don't sweat buckets when you're meeting a friend after 10 years.
I get social anxiety, Obi-Wan.
So have you. Grown more beautiful, I mean. Well, for a senator, I mean.
Sheeparoonies, Anakin. Get this lad on Love Island with lines like that.
You're beautiful for a senator. That's straight out of the negging playbook.
Yeah, this was a long, long time ago, Kwai. 2002. Different time.
Yeah, there's nothing in the code about flirting.
We will find out who's trying to kill you, Padme. I promise you.
You're like me with the wild promises. Digging yourself a hole, Anakin. Next thing you know, you'll be forcing your Padawan to train the Chosen One to save face.
Noted, my Grand Master, Qui-Gon.
Security, not Jedi. It's overkill, Master. Investigation is implied in our mandate.
Jeez, Obi-Wan. You let him speak to you like that.
See, Anakin, if I had spoken to Master Kwai like that, I would have felt the firm end of the back of his
You
hand.
do that and I'd have been straight on the phone to Jedi Social Services.
Padawans these days.
Mr. Bustin' with happiness seeing you again, Annie.
She hardly even recognized me, Jar Jar.
I barely recognized you. You're a big strapping lad.
Thank you, Grand Master Jin.
Oh, you were fishing for compliments. I should be mindful of that.
Sam, there can be no mistakes this time.
Seems a very low success rate assassination attempt for someone who can't afford any more mistakes.
She covered the cameras. I don't think she liked me watching her.
Why does that come as such a surprise to you, Anakin? Have you ever met a woman?
He didn't have a strong male role model, Obi-Wan. The Force is a well-known sleazebag.
Don't watch them while they sleep. Makes sense.
I can sense everything going on in that room. Trust me.
So the camera being turned off isn't sinking in. You turn to using the Force as a camera.
Bit weird, Anakin, mate.
Don't use the Force to spy on them.
I'd much rather dream about Padme.
You know what I'm going to say?
Don't go around saying, I want to dream about you in earshot of them sleeping.
She really has a look of, why are you doing this again?
Anakin. But you already burst in and pretended to lightsaber poisonous bugs off her.
This time it was for real.
Very high-risk move for someone that hates flying.
Oh, you know, Master, I couldn't find a speeder that I really liked.
I was about to die, and you're trying to choose a speeder.
It was a joke, Master.
Spent as much time practicing your saber techniques as you do your witchy with rival Master Yoda as a swordsman.
How can you be so charming and witty at times like that, and then so terrible with Padme?
I'd get all nervous and flustered, and then when I'd see her, I'd just blurt out something stupid about how I've been dreaming about her, or compare her to a nutrient-abundant soil. I mean, what was that?
Here we have the Glock 18, a legendary machine pistol only known because of games like Modern Warfare 2 and Battlefield 3. And you know what? I fell in love with this gun because of Modern Warfare 2. What about you, Charles? Okay, and to be clear, Charles has also been banned from mentioning 13% or 50% during this video.
Why is that, Michael?
The Glock 18 is a automatic version of the Glock 17. In fact, it's been made since around 1987. You can see here, it doesn't have what you'd say, how would you say it, a switch?
Oh, no, a glizzy.
That's a hot dog. So right here, we actually have a selector. We have semi and we have auto. This is such a misunderstood platform. It is shrouded in mystery. Some say it was made when Catherine Glock was born. We actually don't know exactly. But today on Grand Thumb, we're going to be delving into it. We're going to be talking about it. We're going to be shooting it. And we're going to be looking at it from what perspective, Charles?
From our perspective.
Of course, before we get into that, who do we have to thank, Charles?
We have to thank one of the biggest sponsors of this channel, Smelly Indian Dudes. Great people. You walk in there.
The Sonoran Desert Institute, we have to give them a big thank you. Charles does have a tumor in his brain. We don't exactly know what he's going to say. The point is, if you're looking to get your start in gunsmithing, they are awesome. We love them because they support the channel and they keep the content. What, Charles?
It's free, it's flowing, it's American.
What can we not forget?
Primary Arms, providing you with whatever full-auto machine pistol optic you could dream. Don't let your dreams be memes. Let them provide you with free Skittles.
You know what? They actually had to make a Skittles patch because of us. Now, moving from there, we think you should get better at shooting. And you should be doing dry fire to get better at shooting. And what do we recommend?
Mantis. You shoot without the freak out. Gun like that, Maul, Mantis, no problem.
So Mantis is going to turn your gun into a dry fire machine. All of my employees have stolen all of my Mantis lasers.
You're saying that because we grabbed them before we filmed.
Yeah, they took all of them. But we love them. A big thank you to them. Go check them out. And finally, all ammunition provided for by AAC. So big thank you to them. Now, let's get into the video. Right here, we're going to be running a drill so you can control the weapon the best. Now, Charlie is a grandmaster in USPSA, so if he can't do it,
that's a lie.
He's like, he'll do real stolen valor to strangers on the street, but not USPSA stolen
Real
valor.
stolen valor is not as serious as USPSA stolen valor.
Ever since he shot competition, like, nobody likes Charlie.
He hasn't
right now.
been the same.
Yeah, he hasn't been the same.
Well,
He's a fucking asshole now.
is...
So we have the Glock 18 right here. Now this is actually the factory magazine. The factory magazine is a 19 round, so it's a 17 with a +2 base. So we'll go ahead and we'll start with that, and we'll see who does best. Probably not me, because I'm a disabled veteran. That's 2 right there.
Yeah.
And then the rest, but that was actually, I had 19 rounds. You guys only have 17, so actually we can just go ahead and call those good. And I'm all in. Okay, here you go.
I hope it works like that for me.
Oh, hey, Spy Kids.
Oh, hey. Hey, Charles's personality's on pistol. He probably is going to get so pissed if he doesn't win. Stand by. Up.
Ah, just 1 out. Beat Mike.
Debatable.
Not debatable at all.
Oh, look at all that vertical stringing. Like, what are you doing with all this ammo I'm giving you to get to shoot?
Oh, I'm making sure I only get 1 out as compared to 2.
To be clear, we have established that I shoot guns that nobody shoots
better.
So theoretically, should I shoot this pistol better than other Glocks?
You played enough Modern Warfare, didn't you?
Yeah.
I win!
Now, I want to be clear here.
Yeah.
That I have no excuses.
Now, the Glock 18 is firing at 1,200 rounds a minute, pretty fast. Now, we're going to be practicing another technique of shooting the Glock 18. How would you describe it?
It's Glock with a switch, so we're going to pretend that our ops pulled up on us, and this is the Chicago drill. You have to try your best, but the winner is the guy who actually makes less rounds on target.
Okay, on you.
Hey, Doc!
Pull up, bitch!
Strap! Oh!
Not too bad.
Let's see
I got him.
1, 2, 3, 4, 12.
It just seems a little unrealistic.
I have like 5 unaccounted for rounds, which is fine by me.
Yeah, so you have 12. So in order for me to win, I need to get less than that. So.
Oh,
see what I'm saying? But you have to try. That's the thing. Oh.
That was good.
Oh.
6, 7, 8, 9, 10, 11.
Wow.
Yo.
That was really, Micah. Do you think you can do any better than us?
Yeah. I do. Try to make as many impacts as possible, but you win if you don't make impacts.
All right.
Correct?
Yeah.
Up! Calm down, Jamal. Don't pull out the 9.
Micah might have won.
That was a good one. The saying was good.
Whoa, calm down, Jamal. Don't pull out the 9.
It's a very popular video, and
he got 10.
Dang, he won. Okay, wait, hold on. Jeremy Sutton can still win.
Jeremy, you're gonna do it?
Yeah.
Why'd you take off the Spy Kids glasses?
Jeremy.
Up. Oh, snap. 8, 9, 10, 11, 12, 13. The next thing I want to show is going to be transition. So, obviously, going between targets, being able to deliver fast shots is nice. And the Glock 18 does make that very easy. I would say the strength of the Glock 18 is certainly in the controlled burst going between targets. You ready, Micah?
Yep.
Whew, that was a tight group right there. You see that one? Nice. Cool. So we've done a little bit of shooting here. Let's go ahead. Let's talk about the Glock 18 and explain what makes it a little bit amazing. Now, we have done a lot of shooting. Actually, like a lot of shooting. Let's do some talking. The Glock 18 is a very interesting machine pistol. It actually came about due to special operations asking for this, well, specifically counterterrorism forces within Austria. Now, the Glock 18 has been made since around 1987. There have been changes as generations of Glock have improved, but near as I can tell, and from what I have seen, the Glock 18 is perpetually stuck at the Gen 3 model. There have been no changes beyond Gen 3. It is stuck there. There are no optic cuts for it. So if you want to do any type of machining or any type of optics mounting to your Glock 18, it must be done on your own, and there's not a whole lot of clearance there. Now, getting into it, if you're not familiar with the Glock is a very simple system, and it is selective fire, that being both semi and full. On full, it does have a cyclic rate of around 1,200 rounds a minute. That is incredibly fast for a machine pistol, and if you're not well trained, it can definitely get away from you. A machine pistol may seem like a really crazy idea because you're taking a handgun that's already quite lightweight, and although 9mm is controllable, when you're firing it at that cyclic rate, it can really kind of take off on you. But when you put it into the hands of very well-trained individuals, it becomes kind of a different weapon. It becomes a very effective weapon. So the 18 has been used by plenty of counterterrorism forces. It has been mounted with a stock to fire. It has been adapted into chassis. But probably the biggest application I've seen of the Glock 18 was with U.S. Special Forces. Specifically, it was used for clearing mud huts in Afghanistan or clearing buildings where they just had to be tied in, and where the ability to fire off a quick burst and to be able to get those rounds quickly on a target was very effective. But you do need to understand that the Glock 18 has 100% been used in real world. I believe, from what I've seen, only from military and special counterterrorism operations, but it is most definitely used. Now, getting into it, the Glock 18 is slightly dimensionally different from your typical 17, although everything is about the same with the exception of the switch that can trip the sear and some differences within the internals on the frame itself. So when it comes to the Glock, I've always been a bigger fan of the Gen 3 compared to the 4 and 5. In fact, the Gen 3, the finish is nearly indestructible. On the Gen 4 and 5, they changed the finish, and it's not nearly as good as the Gen 3s. So being that this is a Gen 3 gun, I actually kind of love it quite a bit. The barrels on Glocks are quite interesting. Polygonal rifling to increase barrel life, and in addition to that, they are also cold hammer forged. It's almost like the Glock was made to be a machine pistol, because every single Glock is made in that fashion, and it works out extremely well on the Glock 18. Recoil on the 17, recoil on the 18 is extremely minimal. So long as you're gripping it well and you're getting a good pistol grip on it, especially when you're firing short bursts and going across targets, it becomes extremely effective. I think that's where it really shines. Of course, you know, for video use, for showing you guys, it is fun just to lay down on the hammer. But when you're talking about tracking a moving target and firing bursts as he's moving, that's an incredibly effective technique with the Glock 18, delivering a literal hail of bullets onto a target to ensure that you're going to neutralize it. Now, moving from there, the Glock Gen 3s do come with the most rudimentary of plastic sights, but they absolutely work. You can, of course, upgrade sights, but honestly, as this thing is taken off in burst, you're not really tracking them nearly as well, and you get what you get. I find that the kind of recovery is definitely on between those bursts when it comes to this. With a comp and running some type of dot on there, I am tracking the dot through the majority of the recoil simply because the comp is, you know, controlling it so well. We'll talk more about that comp in a moment. Moving back from there, we do have our standard rail on the bottom of the Gen 3. There are Gen 2s that lack that, so it's going to be a little bit more difficult. And then the trigger is just the standard Glock trigger that we know and love. So if we get into it right here, filling into that trigger, standard kind of mushy Glock trigger, we have that 5.5 pound pull, and then on the reset, no reset because it's auto. But on semi, you have a standard Gen 3 trigger. Nothing really to write home about, but incredibly effective, and if you train on it, you're going to be very fast on it. Takedown on the 18 is actually hilarious because the ATF continually messes it up. But if you're going to take down a Glock, it's very simple. It's just like a normal Glock. You're going to pull the trigger in a safe direction, a mountain, and then you're going to pull slightly back in the slide, depress it so that you can let it go. But on the 18, compared to every other Glock, it needs to be in semi. So it was really funny to me to watch the ATF firearm experts unable to take down a automatic Glock because he didn't know that most basic of things. So if you don't know that information, I would be hesitant to call yourself an expert. Micah, agreed?
Yeah, if you don't know that information and the agency hiring you is also incompetent, then is there any competent agency regulating firearms?
No.
Cool.
Cool. End of story. Moving from there, on the switch, it's not really something that you're going to be activating kind of on the fly, although it is quite easy to switch between the two. A lot of people, of course, when they first see this, mistake this for a safety. They go, oh, cool, Glock with the safety. Sure.
No, it's Glock with the switch.
Glock with the switch. And like we talked about before, when it comes to the auto selector on the 18, it is incredibly robust. Famously, Iraq veteran fired his until the guide rod melted and then continued to fire it. These are nearly indestructible when it comes to machine pistols. They will just continually run and run and run. Now, the Gen 3 grip isn't the grippiest of grippies. It's not like that mental word grippy, so you definitely want to put some type of grip tape. We have goon tape on this. Big goon tape guy. Big
goon tape guy.
Big goon tape guy.
Well, you gotta ask people, is it grippy?
It's grippy. No, I do know what that means.
Sorry, you're
with
almost
it.
40. I gotta clarify your internet.
I'm not 40.
I said you're almost 40.
I'm getting close. A lot of people will complain about the Glock grip angle. That's probably because they don't fire enough. The aggressive angle actually allows you to stay on target a lot easier. I do love the grip angle. I'm obviously a huge slut for the Glock 17 Gen 3, and the Glock 18 is just my Gen 3 17, but better in every single way. So this is something that is going to be very difficult to get, unfortunately. You have to be on an SOT. There's very few in public circulation, and it's a real shame. There shouldn't be any regulation on these, and yet it's very difficult to come by them. So if you get to shoot a Glock 18, if you procure one from a NATO Death Squad member, definitely keep it on you. This is a wonderful, wonderful, incredibly effective and incredibly versatile weapon because it can go between both firing modes. One last kind of note here, when it comes to mounting anything on your Glock 18, I think it is best to keep it as stock as possible because these Glocks get hot. Micah, how hot does this thing get?
Stupid hot. It took us all by surprise once we grabbed it. Yeah, if you weren't wearing gloves.
I was watching heat waves coming off that thing. Like, it just heats up fast. So the problem is that any screw that you have, any type of Vibratight or Loctite, is coming loose due to the excessive vibration, due to the excessive heat. It's very hard to keep those screws from backing out. So on our comp, that thing's backing out off all the time. Despite the use of Hot Lock or Vibratight or whatever, it's just, you're fighting a losing battle unless you have a better design. I would not recommend the KKM comp on the Glock 18. They just tend to not work. We'll probably be trying one of the new Radiant Ramjets or something like that. When it comes to our optic, we did opt for the LED model. They're virtually indestructible. And the big thing is that we hot locked all the screws in and we hot locked the entire freaking optic in with a very powerful glue. So I didn't want to have to change the batteries. This guy is, for all intents and purposes, permanently affixed. Same goes for the front sight.
Then why are you missing a screw, Mike?
Oh, because so on that screw, we need to get it cut to length because this is a custom cut for the 18, so it was pressing on the ejector. So I wanted to get that out just so we could make sure this thing ran somewhat for the video. We are running the Landers Weapon Systems sights, which are wonderful for optics, and that is our custom one. But in any case, gentlemen and ladies, we probably got some ladies in here, the Glock 18 is incredible. I love it. Probably my favoriteest Glock in the entire world. Micah, is it your favoriteest Glock in the entire world?
Yeah. No, yeah, it is.
Well, really?
Yeah. What else would be a cooler Glock than the Glock 18? Like, genuinely, I don't think there's a cooler Glock.
Cool. Well, we got Micah with us. Final note is that the factory Glocks, like we talked about, are 19 rounds. They have that little extendo right there. And you have the Glock 18. Ladies and gentlemen, get out there, get training, get good with whatever you have. You have a 17 Gen 3, you know what? You're just about there. Just get Ben Stoker fast at that. Get Mojo fast at that, and you're going to be absolutely fine. And, guys, we love you so much. Thank you for watching. We got nothing else for you except for dad advice. And the dad advice today is going to be from Micah Mayfield.
Me?
Come on in. Yeah, come on in.
All right. You waved me in that way, but I'm going to walk in this way.
Yeah. What's your dad advice for today?
Oh, man. My dad advice is to, I'm not going to give dad advice. I'm going to give gun advice.
Oh, okay.
All right, gun advice.
Okay.
If you're really into shooting pistols or ARs, try getting into a realm of shooting that you've never done before. Try getting a bolt gun.
Yeah.
Try grouping real tight. You might just get addicted. You might rekindle the flame, your love for shooting.
Shooting is fun.
It is fun. And I think everybody should have fun while learning. And that's what I got for you.
And the more you know, and the star flies in. Can you do that? Can you do the?
Yeah.
Okay.